This lesson is a direct continuation from the lesson on disjoint sets and counting. So if you haven't watched it, I really recommend you watch that lesson first, and then you can come back to this one. We ended that lesson with a really important formula that showed us that the cardinality of A or B is the same thing as the cardinality of A plus the cardinality of B minus the cardinality of A and B. We got that formula by first counting all the elements in A, then we counted all the elements in B, and then we subtracted off the middle part because we've double counted it. In that lesson, I remarked that I was going to extend this to deal with 3 or even 4 sets, so that's what this lesson is about. In this lesson, we're going to learn how to count larger sets. So to do that, I'm going to start off by actually drawing 3 different overlapping sets, and then we'll figure out how to actually count the number of elements in that set. So if we have 3 overlapping sets, I want you to see that this set over here is going to be A, this is going to be B, and this one over here is going to be C. The elements contained in this piece over here are going to be the elements that are contained inside of every set A, B, and C. So for that reason, we call this piece over here A and B and C. After this, I want to look at this little fan piece over here. I want you to see that you can make this piece by taking all of C and then getting rid of all of A and then getting rid of all of B. So in other words, we'd call this piece over here C without A and without B. And similarly, this piece over here would be A without B and C, and this piece over here would be B without A and C. Now after this, we should figure out how to make this little piece over here. To do this, we start by taking A and C, and then we just go ahead and remove all of the parts that are inside of B. So this part over here is going to be A and C without B. And so similarly, this piece over here is going to be A and B without C, and then this piece over here is going to be B and C without A. Now if we wanted to figure out what A or B or C is, we could go ahead and repeat the exact same thing we did up here, and then we could write it in terms of all the disjoint parts and figure out all the cardinalities. But I bet you can imagine that this is going to be way too much work. So instead, I'm going to start by writing A or B or C, and then we're going to use the exact same idea that we used to derive this formula the second time. Let's start by adding A again, which I'll denote by a bunch of triangles as I did over here. I want you to notice this time, however, that A is actually broken up into 4 disjoint parts, and not 2 like it was up here. Now again, I'm also going to add B this time, and I'll also denote it with a bunch of circles. And of course I'll add C, but this time I'll denote it with a bunch of squares. Okay, so I want you to realize that A or B or C is this whole piece over here. And it's actually broken up into 1, 2, 3, 4, 5, 6, 7 disjoint parts. Now we've counted this piece one time, this piece one time, and this piece one time. But these pieces have been counted 2 times, and this piece right in the middle has actually been counted 3 times. So just like I did over here, I'm going to subtract off A and B, which is going to be this piece over here. But then I'm also going to need to subtract off B and C, as well as A and C. So let's start by actually removing A and B first. Now as you can see, by doing this, this piece has only been counted once again, but this piece is still counted twice. So now let's go ahead and remove B and C. Now this piece has also been counted once, and this piece has been counted once. But we still need to remove C and A, so we're going to go ahead and subtract off C and A as well. Okay, so once we've got all of this, I want you to notice that we've counted this piece exactly once, this piece is counted once, and so is this piece, this piece, this piece, and this piece. But unfortunately, the piece in the middle is not counted at all, because we just subtracted away each 3 of these countings, so we have nothing left in the middle. And therefore, if we're going to include the middle, we're going to have to add it back on one more time. So I'm going to go ahead and add A and B and C. So this is actually a pretty big formula. It takes up 2 lines after all. But it's not really that complicated. To work out the cardinality of A or B or C, you first add each set on 1 at a time, then you subtract off each set 2 at a time, and then you go ahead and add on every set 3 at a time. This actually continues even as you have more and more sets, and we call this idea here the principle of inclusion and exclusion, because you include, then you exclude, and then you include again. Now, just before parting, I'm going to give you one more example, just so you can see how we can use this to do something useful. So, for this problem, we're told that we started with 40 musicians, and of them, 15 play the guitar, 20 play the piano, and 25 play the drums. Of these, 8 play the guitar and the drums, 6 play piano and guitar, and 10 play piano and drums. And we want to figure out how many of them play all 3 of the instruments. So we understand that we have 15 people in this group, we have 20 people in this group, and we have 25 people in this group. We also understand that 8 people play the guitar and drums, so in this whole area, we expect to have 8 people. And then we have 6 that play piano and guitar, so we expect 6 in this whole area over here. Now what we want to find is the number of people that belong to this group inside the middle. Now of course, we should start by actually writing out the formula in the case of the guitarists, pianists, and drummers. So just as we said before, we start by adding each person who plays one instrument, so every guitarist, drummer, and pianist. Then we subtract off everybody who plays 2 instruments, so the guitars and drummers, the guitars and pianists, and the pianists and drummers. Then after this, we just go ahead and add on everybody who plays all 3 instruments. At this stage, we just want to replace each part for the numbers we know. We know that we have 40 musicians in total, of which 15 play the guitar, 20 play the piano, and 25 play the drums. We know that 8 play guitar and drums, 6 play piano and guitar, and 10 play piano and drums. We just don't know what this number is. At this stage, we can just go ahead and add up all of the numbers. We know that 15 plus 25 is 40, plus 20 is 60. And then, minus 8 minus 6 is the same thing as minus 14, minus 10 is minus 24. And now we just subtract 24 from 60. 60 minus 24 is just 36. At this stage, we can see that 36 plus some number has to be the same thing as 40. Of course, that means that this number has to be the number 4, because 36 plus 4 is 40. So that means we know that 4 people play the guitar, piano, and drums. We should sanity check this though. We can start by writing 4 in this section over here. Now, since we know that 8 people play the guitar and drums, then we're going to have 4 people over here, because this whole section has to be 8. Since we know that 6 people play the piano and guitar, then we know that 2 people go here. And since 10 play the piano and drums, then we know 6 people go here. Now after this, we can work out how many people belong here by realizing that 15 people play the guitar. In here we have 8 and then we have 10, and that means we have 5 more that play the guitar. So there are exactly 5 people that play the guitar but do not play the drums nor the piano. Similarly, we have 20 people that play the piano in total, but we have 10 here and then another 2, so that's 12. And that means we have 8 people that play the piano but not the guitar nor the drums. And then similarly, we have the people that play the drums but not the guitar or the piano. We know that we have 10 people here and then another 4, so we have 14 in total. 25 play the drums, so that means 11 of them play the drums but not the guitar and not the piano. Now if you'd like, you can sanity check this. Add up all of these numbers and they should add up to this 40 over here. So given this information, we managed to segment each of the musicians up into their own groups, and this allowed us to determine every single possible place where you'd put each musician. So now that you've seen all the examples I wanted to show you, let's go ahead and just summarize this lesson. We found this really important formula that says if you wanted the cardinality of A or B, you just get the cardinality of A, then add the cardinality of B, then subtract the cardinality of A and B. We said that you can continue this formula up to even more than just 2 sets. For example, in the case of 3 sets, which we had over here, you just start by adding each set 1 at a time, then you subtract off each set 2 at a time, and then you just add on each set 3 at a time. Or in other words, you just add on each set 1 at a time, then subtract off every pair of sets, then just add on every triplet of sets. Now up until this point, we spent all of our time looking at abstract sets, sets that can have basically anything you want in them. But in future lessons, we're going to drill down on some really special sets that are really important to a study of mathematics, namely the numeric sets. So I'd like you to join me in the next lesson where we talk about the numeric sets, and therefore I'd like to end this lesson on disjoint sets and counting. Thanks for watching another Trina video. If you want to say thanks, you got to show your friends. Or maybe you should just visit us at trina.org, where you can track your progress and have access to questions and heaps of other awesome stuff. Or maybe you should just like and subscribe. That works too. But either way, I'll see you next time.